going to review all of the rules that we learned for exponents. So we have the law of exponents on slide 17. When multiplying like bases, this is a product of powers. When you are multiplying your like bases, you're going to add the exponents. Let me zoom in a little bit more. So x to the 7 times x to the 5th. We are going to add the 7 and 5. So I'm going to write it as x. Do y'all remember how to do the exponent? It's, yeah, shift and then the less than or greater than.
Mine's not working. Where's the control shift?
Maybe it's control. Mine's different because I have a Mac. Y'all help each other out on doing the exponents.
It's a control greater than.
Control greater than, and then you have to hit control greater than again to get it back down?
Yes.
Okay. So this would be x to the 12. Okay, then the next one, we have 4 to the 3rd times 4 to the 3rd. So let's show our work. It would be 4 to the 3 plus 3, which equals 4 to the 6th power. So anytime you have like bases, so this is a base, x, this is a base, x, you add your exponents. They're like bases. And then the other one, we have the 4, then we add the exponents. We're going to leave it just as 4 to the 6th on this one. Okay, the next problem. This is what we did last. When raising a power to a power, it's like this situation. X to the 2nd power, all to the 5th power. We are going to multiply the exponents. Because that exponent means repeated multiplication. So it's x squared times x squared times x squared times x squared times x squared all 5 times. So that's why we multiply them. So this will be x to the 2 times 5, which equals x to the 10. Then we have 6 squared to the 3rd power. See how we only have one base and we have this parenthesis? That's how you know you're going to multiply your exponents and not add them. So this would be 6 to the 2 times 3, which equals 6 to the 6th power. Power of a product. When raising a product, so a product means two things are being multiplied to a power. What is going to happen to this exponent? That means AB is being multiplied to itself 3 times. So we are going to send the exponent to each term, each variable, each term. Multiply exponents. So if I were to use my scribble tool, I'm going to take this 3. Oh, that's not the scribble tool. That is the line tool. Do a scribble. And take this to the A and then take it to the B. Since both of them don't have an exponent, that means there's an exponent of 1. And I would multiply the exponent of 1 times 3, which gives us 3. And then the exponent of B is 1. So I'd multiply 1 times 3, which is 3. So A to the 3rd power and B to the 3rd power. So then the same thing is true here. We have m to the 2nd. So I'm going to send that 4 over to the m and then send the 4 over to the n. And I'm going to multiply their exponents. So m would be raised to the 8th power. And n would be raised to the 5 times 4, 20th power. If you did not watch the lesson about raising terms to a power, then you need to make sure to do that, because I talk about this in that, I think it's only 15 minutes from Thursday. All right, let's go to the other side. 0 exponent, a number or a variable to the power of 0. That means it equals 1. So put always equals 1. Anything to the 0 exponent always equals 1. So x to the 0 equals 1. Then here we have to send our 0 to the 3, so that'd be 3 to the 0, and send our 0 to the x, that'd be x to the 0. So they're both to the 0 power, meaning that equals 1. Negative exponent. Any number or variable raised to a negative power is, do you remember what we do with the negative exponent? What do we find? How do we deal with that? Do you remember the word reciprocal?
Yes.
Okay, a number or variable raised to a negative power is the reciprocal with a positive exponent. So if I have x to the negative 4, I flip it. So the x actually goes on the bottom. So it'll be 1 over x to the positive 4. I could write it like that.
There's a golden. Oh, right. We gotta go.
Okay, so I'm going to make my fraction like this. So 1 over x to the 4. You can also leave it like the other way. Okay, and then the other one, we are going to flip it and change the power to a positive. So this would be x over 3, all raised. Oh, I don't like how this is. I'll do it like this. I'm going to flip it, and I'm going to change the sign to a positive 2. And so what that will do is that'll square. Shh, stay quiet. Then you send the exponent in to each term. And then that'll be x squared to the over 9. That's what it'll be. If you can rewrite it in this way, you go for it. But we know that this is a fraction, right? We're good. Good with that? Okay, last rule, dividing like bases. When dividing like bases, what do we do to the exponents? No, multiplying is add. So dividing is the opposite of add, which would be subtract. Subtract the exponents. So this would be 5, and then 6 minus 4, right? Equals 5 raised to what value? And the next one is 7 squared over 7 to the 5th. So we'll do the same thing. 2 minus 5. 7 to the 2 minus 5. What does that equal? What is 2 minus 5? Negative 3, right. But we can't leave it with a negative 3 power. So we are going to rewrite it as what? The reciprocal with a positive. So this would be 1 over 7 raised to the positive 3. Okay, so these are all of the rules that we have learned so far dealing with exponents. So now you're going to practice them, and you can write these in your journal and then just put a picture if you want on slide 18. So this is your assignment. On Wednesday, I'll let you ask questions, but this is your assignment to finish these, okay? Write them down in your journal, work out each one, then upload a picture, okay?